Welcome to Study Loop.
So to solve this problem, let's go to the problem in the book. So here is the problem. So in this problem, we are given an unknown base or a base from the list here we have, and we are given a sample of this which we actually dissolve zero point 0.3 gram of the base in enough water to make it 25 milliliter, and then we titrate the solution with zero point 0.1 molar HCl and record the pH as a function of the added acid, resulting in the titration curve of this. So based on this curve and based on the table here, we have to answer the question. So first question here is, what is the volume of added HCl at the equivalence point? So the equivalence point here, as we know that the equivalence point is basically the sharper portion of the titration curve, and equivalence point is halfway through the steeper portion. That means it will be around somewhere here, and the volume here is we can say it is 31. So the pH at the equivalence point is, oh no, not pH, the volume of acid added at the equivalence point is 31 milliliter. And then in the second one we have to say what is the pH at the half equivalence point. So since the equivalence point it is at 31 ml, that means we can say that the half equivalence point is at the half volume of that, which will be around 15.5 ml. So at the 15.5 ml, the pH will be somewhere here, and from here you can see that if we just draw kind of a straight line from the titration curve to the pH axis, then the pH here is basically 11. So pH at the half equivalence point is 11. And in question C, we're asked what is the molar mass of the unknown base. So to find the molar mass of the unknown base, we first have to calculate the number of moles of acid. So the number of moles of acid at the equivalence point is basically the concentration of the acid, which is 0.1 molar or zero point 0.1 mole per liter, multiplied by the volume of acid we added up to the equivalence point, which is 31 ml or 0.031 liter, and the product of this is 0.003 mole. So this is the number of mole of the acid um, at the equivalence point. And as we know that at the equivalence point, the number of mole of acid is equal to the number of mole of base. That means at the equivalence point, we will have 0.003 mole of the base. Now we know the number of moles of the base, and we know um, the mass of the base we are adding, which is 0.3 gram. That means from these two, we'll be able to find the molar mass of base, which will be basically its mass over the number of moles. So the mass is 0.3 gram, and number of moles is 0.003. And from this we will have the molar mass as it is mole, so it is 100 gram per mole. So this is the molar mass of the base, 100 gram. And then in next question, in question D, we have to calculate the pkb and kb of the unknown base. So at this point we have to find out which is our base we are using here. So we can do this in two ways. First one is we can compare the molar mass we have just calculated with the molar mass of these three. So pyridine here has a molar mass of 79.1. Then aniline has a molar mass of 93.13, and triethylamine has a molar mass of 101.19. That means that since we have calculated the molar mass is 100 gram, which is close to the molar mass of triethylamine, that means the base here is triethylamine, and that's why um, so we have already answered the question 5 or question E here, which says the likely identity of the unknown base is triethylamine. And then we can, so now we can answer the part D, the problem D, where we have to know the kb and the pkb of the unknown base. So the kb of the unknown base is 5.6 times 10 to the power minus 4, and that means the pkb will be just the negative log of this 5.6 times 10 to the power minus 4, and this will give us a value of, if we just take the negative log of its kb value, it will give us 3.25.